To the sixth and probably last example about the use of the Laplace transform in circuits. So let's crack on and draw our circuit as always. So we're going to have a generator, which is going to give us a different of potential, then a resistance, and over here the circuit is going to be open, and the bottom tier is going to be open as well, but here in the middle we're going to have a capacitor connected like so. So here we have plus minus V0 of t. The capacitor C is going to be of 1 farad. The resistance R is going to be 1 ohm. And this is just Vg of t, our generator. We also know that the graph is actually like so, with 1, 1, and 0, and this is just Ts, and this is Vg of t, V. So our problem is actually saying in the circuit find the voltage V0 of t for t greater than 0, assuming that the capacitor is discharged in, well, at t equals 0 minus. We also know that R is 1 ohm, as I basically draw there, and C is 1 farad. The voltage Vg of t is as shown above, which basically refers to this one. Okay, so we really have to find the voltage V0 of t for t greater than 0. So we can actually say that our Vg of s is equal to the integral between 0 minus and infinity of Vg of t e raised to the power of negative st in dt. So the integral between 0 minus and positive infinity of t e to the negative st in dt, which we can actually solve this by parts, and it will actually give us 1 over s e raised to the power of negative st t evaluated between 0 and 1 plus the integral of 1 over s e raised to the power of negative st in dt. So this is just 1 over s e raised to the power of negative st t evaluated between 0 and 1, as I said, and the other one is negative 1 over s squared e raised to the power of negative st evaluated between 0 and 1, which actually gives us negative 1 over s e raised to the power of negative s minus 1 over s squared e to the power of negative s plus 1 over s squared. So we're just getting started because now that we have found this guy here, we can actually say, okay, let's take the time t less than 1. If we take the time t less than 1, then we will basically have Vg of t equal to t, and the Laplace transform of t will be just 1 over s squared. So the equivalent circuit of Laplace in this case will be the generator, the resistance, which is still gonna be a resistance, then this end is open, on this other end is open, and here the capacitor, which was here, is just gonna be a resistance, like so. Because remember, we just said that the problem just said assuming that the capacitor is discharged at t equals 0 minus. So if we take the time less than 1, in this case is going to be, you know, just a resistance. It's not going to have it just depended by the voltage here, and it's not going to be a generator, just a resistance. So basically in the equivalent circuit of Laplace we will have 1 ohm, which is our resistance R, and our capacitor, since it was C, but it's going to be 1 over S C. So basically Vg is R plus 1 over SC I. V0 is 1 over SC times I, which actually tells us that V0 is Vg over SC times 1 over R plus 1 over SC, which gives us V0 equal to Vg of S times 1 over RCS plus 1, and therefore we have that V0 is equal to 1 over S squared times 1 over S plus 1. So notice here that this one is a double fold, and this one over here instead is a simple pole. So now we have a single pole, a simple pole, and a double pole. So since we have those two things here, we will basically have A01 over S plus A02 over S plus A1 over S plus 1. So now let's find the simple pole. Okay, so A1 will actually be just like before, you know, in the other examples, S plus 1 over S squared times S plus 1, which will give me 1 over -1 square, and just substituting the value, equal to 1 over 1, so basically 1. So now let's find the double pole. So in order to find the double pole, we will basically have S squared times 1 over S squared times S plus 1 evaluated between, well, in S equal to 0. So those two guys cancel out, and this will actually give me 1. So I will basically have 1 over 1 factorial times d ds of S squared times 1 over S squared times S plus 1, everything evaluated for S equal to 0. So 1 over 1 times d over ds of 1 S plus 1, evaluating S equals 0 again. So it will be 1 times negative 1 over S plus 1 squared still value for s equal to 0. So if we plug in s equal to 0, we will just have -1. Therefore, v0 of s will be just 1 over s plus 1 plus 1 over s squared minus 1 over s. And the Laplace transform will be just e raised to the power of -t plus t minus 1. But this is just the solution for the nominal time. So it basically means that we have to find the solution for the time 1. So Vg of t would be e to the -1, so basically 1 over e. Now, if we go on for t equal 1, we will basically say, okay, the capacitor is charged now and it's gonna be our power supply. So the equivalent circuit of Laplace in this case will be this one. So here we're not gonna have anything, and there's not gonna be the power supply anymore, but we will still have the resistance, and our capacitor is basically turned into a power supply, like so. And here is open as well. I'm basically going to say that in this case, we will have d in dt of I equal to -I. So the dt of v0, just like I will be -v0. Therefore, the solution in v0 is v0 of t equal to c0, some constants, e to the -t, which is just c e to the -t minus 1. Now, in the instant, at the instant and well, I can just say at our initial instant 1, I had v0 of 1 equal to 1 over e. Therefore v0 of 1 is just going to be 1 over e to the negative t minus 1 for t greater than 1.